diagram. Now you see here the resting membrane potential is -60, but it is not stable. It is gradually decreasing. The negativity inside the nodal fiber is gradually decreasing to -40 millivolt. Okay, and this is known as pacemaker potential. Now, what causes this gradual decrease in the negativity inside the nodal fibers? Okay, so remember there are very special channels in the SA node which are known as sodium leak channels. Sodium leak channels. Now, since they are leak channels, so they are non-gated channels, and they allow the sodium ions to diffuse from outside to inside. So you know the sodium ions are positively charged. They also allow some calcium ions to diffuse. So sodium and calcium carrying positive charges, okay, they move into the fiber, and the inside is gradually is moving towards -40. Okay, now this -40 millivolt is a threshold potential, and threshold potential is that potential is the minimal change that is required for an action potential to take place. Okay, so the moment the membrane potential touches the -40 level, okay, then the vicious circle starts, and the voltage gated calcium channels open, which allow the positive charges to rush in, causing this depolarization. So this pacemaker potential is because of the presence of the sodium leak channels. And when these leak channels were first time they were discovered, they were named as funny channels. FUNNY, funny channels at that time. Okay, so many of the books they also describe them as funny channels. Basically they are sodium calcium leak channels which are only present in the SA node. So because of this constant leakiness of the sodium ions gradually into the fibers, the negativity inside is gradually reduced till it reaches -40. Okay, and the moment it reaches the -40, then what happens that voltage gated calcium channels open, and the calcium ions they are diffused into the fibers, which results in this depolarization. And remember that this depolarization in the SA nodal fibers is because of the opening of the calcium channels and not sodium channels, like in the ventricular muscle fibers. Okay, in the ventricular muscle fibers, phase 0, that is depolarization, is because of the opening of the fast sodium channels. But here in the SA node, the fast sodium channels are already inactivated by this low negativity inside the fiber. You know, whenever the membrane potential inside the fibers becomes negative to such a level, -40 or -55, -60, the sodium channels get inactivated already. So the sodium channels cannot open, not at all. But there are L-type calcium channels or slow calcium channels which are open, and they allow the calcium ions to get inside, and the inside becomes positive. This is depolarization. Now at this point, the L-type calcium channels, they are closed, and the voltage gated potassium channels are opened. And when the voltage gated potassium channels are opened, they carry the positive charge out of the fibers. The potassium efflux occurs, and that causes the membrane potentials to go back to resting levels. But at this resting level, at -60, the voltage gated potassium channels are closed. No more potassium efflux. So at that very moment, the sodium leak channels once again take over. And what happens that again that leakiness of the sodium, inward current of the sodium through funny channels, that starts, and once again this thing happens, bringing the RMP to -40, and then the SA nodal fibers again fire, and there is another action potential.